Listen to a discussion in an earth science class.
Okay, today we're going to talk about avalanches. Avalanches are a major safety concern for people who enjoy winter sports, such as skiing and snowboarding. And they can happen at any time of the year, even in the summer months. Okay, let's start today by discussing the most common type, slab avalanches. Simply put, a slab avalanche is the largest and the most dangerous type of avalanche, and it occurs when a solid layer, a slab of snow, breaks off and slides down the side of a mountain. Take a look at this picture of a slab structure while I explain this in more detail. As you probably know, snow on the slopes of mountains has many layers that build up over time. This is called a snowpack. Some layers are strong and cohesive, but other layers are light and weak. That is, they're loose, like sand. An avalanche can occur when a stronger layer of snow is sitting on top of a weaker one and is not solidly connected to the layer underneath. When there's a sharp division from the lower layer, the entire surface of the upper plate of snow slides as one unit on top of the weaker layer and is set in motion at the same time. Think of it as a dinner plate sliding off the table. This solid chunk of snow shatters like a pane of window glass as it tumbles down the mountain.
Excuse me, Professor, but aren't there also different kinds of slabs? I mean, I read that even a light layer, like the soft powder snow I like to ski on, even this kind of layer can act as a slab if it has an even weaker layer below it.
You beat me to the point. I was going to mention that there are different kinds of slabs involved in avalanches, as you can see in this next picture. There's the soft slab type and the hard slab type. The hard slab is stiff and cohesive, old, denser layers of snow or very wind-hardened snow. On the other hand, the soft slab is generally thought of as a shallower and newer layer of snow. There are differences in how these two types of slabs react during an avalanche. Hard slabs cause more damage because they involve larger chunks of hard frozen snow. And while hard slabs are more difficult to trigger than soft slabs, they don't break up as much as they fall. They also spread further and make a much larger avalanche. Okay, so let's discuss what triggers an avalanche. What causes the slabs to become unstable? If you ski, you know we get warnings all the time about how the weight of just a single person traveling on unstable snow can cause an avalanche. And it's true that human activity can trigger an avalanche, but certain conditions, externally and internally, have to exist for this to happen. It has to do with changes in conditions, such as the weather, the temperature, and wind direction. For instance, avalanches will most likely take place after a heavy snowfall. This snowfall can put extra stress on the existing snowpack, especially if it doesn't attach well to the surface layer. The weight of the new snow alone can cause a slab to break off and fall down the slope. Changes in temperature that continue for several hours or days can also lead to avalanche danger. Say if it warms up and the temperatures increase, this can cause melting within the snowpack. This, in turn, weakens some of the upper layers of snow, which can then break off and slide. Okay, look at this image as I explain what wind has to do with it. Okay, wind usually blows up one side of the mountain, the windward side, and down the other side. That's the leeward side. The wind blowing up the windward side carries snow off the surface and drops it on the leeward side. This packs the snow unevenly on the leeward side, making it unstable and more likely to lead to an avalanche.
Listen again to part of the passage. Then answer the question.
Excuse me, Professor, but aren't there also different kinds of slabs? I mean, I read that even a light layer, like the soft powder snow I like to ski on, even this kind of layer can act as a slab if it has an even weaker layer below it.
You beat me to the point. I was going to mention that there are different kinds of slabs involved in avalanches, as you can see in this next picture.